Hello, this is Mr. Wolf. Today we're doing Geometry Benchmark 9, which is called Concepts of Congruence. The Common Core standard for this benchmark is G.co.6. So if you want to Google that standard, you'll find a lot of other resources on this topic. The big idea for this benchmark is that congruence is the mapping of one shape onto another through one or more isometric transformations. So we're going back to benchmark 4, benchmark 6, benchmark 7 isometric transformations. And all we're saying is that if you can map one figure right on top of another one and it exactly fits, then we know that the figures are congruent. Seems pretty obvious. Okay, here are the essential skills that you're going to need for this benchmark. You're going to need to show that two figures are congruent if there's a sequence of motions that map one onto the other. You're going to need to show that two figures are congruent if they have the same shape or the same size. You need to be able to use composite transformations. That means using a combination of transformations, like a rotation and a reflection, to map one figure on top of another. You need to recognize the effects of rigid motion on orientation and the location of a figure. So orientation is the order of the points, and location is where it is in the plane. And last, you're going to need to use the definition of congruence as a test to see if figures are congruent. All right, please remember that we have a difference between congruence and equality. A simple Google search, like I did here, would help you out. So if you're ever stuck, just do a web search. I typed in what's the difference between congruent and equal. I chose this link down here, and they do a nice job of explaining in detail what each means. Of course, we know the difference is equal is generally with numbers, congruence is with figures. Okay, in class I gave you a guided note sheet that looks just like this, except it doesn't have the handwritten answers in there. So now is your time that you're going to copy down these notes onto your sheet. And I'm just going to walk you through here. So if you want to write quickly while I talk, or you can pause, write it down, and then listen. Okay, remember rigid motions are those motions that preserve distances and angles as well as shape and size. Okay, those were 3 transformations. Those were translations, rotations, and reflections. We say that figures are congruent. Figures are congruent if one figure can be mapped onto another using rigid motion. So in the example here, we take CDB, we translate it up here, and then we reflect it across, and the figure is mapped onto the other. So here are those 3 rigid motions again, right here. There we go. Okay, a congruent statement is when we match up corresponding parts, for example, angles or sides. So if we know that quadrilateral ABCD is congruent to quadrilateral MNOP, we know that A is congruent to M because they're the first term. And angle B is congruent to angle N because they're the second term in each one, and so forth. Additionally, since it's a quadrilateral, it also has 4 sides. So side AB is congruent to MN, BC to NO, and so forth. You can even match up the colors on mine here. Okay? Make sure you copy those down. All right, and now I'd like you to try some down here. So it says, now you try some. And I'm not going to show you the answers to mine. I'd rather you just try on your own. Okay, the next term that you need to get down is this, CPCFC. That stands for corresponding parts of congruent figures are congruent. Wow, that's a mouthful. But you'll hear those initials come up a few more times. So let's understand exactly what we are writing down. We're saying that if you have 2 congruent figures, 2 figures that are the same, we can use any of these pairs down here. The corresponding parts are also congruent. So if these 2 quadrilaterals right here, if these 2 are congruent, then I know this angle V right here is congruent to its corresponding angle. Which one corresponds with V? Well, it's R. So I know V and R are congruent. Similarly, I know that segment ST is congruent to segment WX. Okay, so I can now state that WX is congruent to ST. Why? Because of CPCFC. Once we've proven the figures are congruent, then all the corresponding parts are congruent. All right, so in this one, it was a simple translation, maps this figure onto this. In this one, it was a rotation of 270 degrees. That's a positive direction, so that means we went counterclockwise. And over here is a simple reflection that mapped it on to each other. Okay, this next part I'd like you to try on your own. Okay, that wraps up this short video on benchmark 9. So you should have written down my notes and then also done a few problems on your own. All I wanted you to do is get a general idea of the concept, and then when you come into class prepared with this sheet, we'll dive deeper into the concept, and you'll have me there to help you. If you have questions, as always, you can email me or text me at my text number. Okay, thank you.